Today I'd like to talk to you about how to graph these trig functions that we've been studying. So first I want to show you what the functions look like graphically, and then I'll show you how you can graph them. So the first function we're looking at is the equation y equals the sine of x. And when you graph it, it will look like this. So do you notice I have the same pattern running over and over and over again? That is what we call a cyclical function, when the same pattern continues on forever. So I want you now to look at the cosine of x, and it is this graph. Does it look like cosine is also cyclical? And the answer is yes, it is cyclical. So since both sine and cosine are cyclical, we call one cycle of those functions a period. So up here in sine, we're going to look at one cycle. Where does the pattern repeat itself? So we're going to look from this spot to this spot. If I take that and continue it on, it just keeps repeating. One cycle of cosine is also, we're going to look from this spot to this spot. So as you can see, one cycle does repeat. So each of those are a period. The parent function of our trig equation is y equals a sine b of x minus h plus k, or y equals a cosine b of x minus h plus k. Just like on any other parent function we had, a was the vertical stretch. On trigonometry functions, it is called the amplitude. It still is the vertical stretch. H was our horizontal shift, and K was our vertical shift, up and down. Still holds true, A, H, and K on the trig functions. If you notice, we have a new letter introduced here, and that is B. B involves that period, that one cycle. And to find B, you take a 2 pi and divide it by the period of your cycle. From that, we can also see, if I solve for what the period is, it would equal 2 pi divided by b. So let's actually graph our sine function. So again, our parent, with taking away a, h, and k, and this time b as well, is y equals sine x. So if I think about sine, I'm going to look at it with 5 critical points. So again, I'm going to do my values at 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So if I am here at 0 degrees, that is the point 1, 0. If I am here at 90 degrees, that is the point 0, 1. If I'm here at 180 degrees, that is the point -1, 0. If I am here at 270, that is the point 0, -1. And then when I come back here to 360, I'm back at 1, 0. This creates that unit circle we had talked about before, which also helps us see one cycle, one period of sine. So at 0 degrees or 0 radians, we are at 1, 0. So the sine at that, since sine of the angle will equal y over r, sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 360 is 0. So our x-axis is our angle measure. So this is 0. And then I'm going to have 1, 2, 3, 4 markings out from 0. And they are pi over 2, pi, 3 pi over 2, and 2 pi. My y's go 0, 1, 0, -1, 0. So I need a 1 and a -1. You must label your x-axis all the time and your y-axis all the time. So we are now ready to plot those points. So I've got 0, 0, pi over 2, 1, 0, pi, pi, 0, 3 pi over 2, -1, 2 pi, 0. And when I go through those points, I have one cycle of sine. And since I know it's cyclical, that's how come I continued on. But I'm not going to put arrows because it just comes up and back down, up and back down. So our domain for sine on this x-axis is x is all reals. Because when I go to the left or I go to the right, I am using the entire x-axis in this cyclical function. The range are my y's. I can see my lowest is a -1, and I am equal at a -1, and my highest is 1, so I'm equal there as well. So -1 is less than or equal to y, which is less than or equal to 1. Again, I told you on the last screen that amplitude was our A, our vertical stretch. So the highest and the lowest the function reaches is called the amplitude. And notice amplitude will always be positive. The midline is just what it sounds like, the line halfway between the highest and the lowest. So in our case, our midline is right here at y equals 0. So notice again, our period was 2 pi because one cycle to get from 0 degrees all the way around back here to 360 degrees gave me one cycle from 0 radians to 2 pi radians. Now let's graph one cycle of cosine. So again, I'm going to put that little chart up here. That point at 0 radians is 1, 0. This point at pi over 2 radians is 0, 1. At pi radians, I have negative 1, 0. And at 3 pi over 2 radians, I have 0, negative 1. And then back here at 2 pi, I have my 1, 0. So cosine of an angle is equivalent to x over r. So cosine of 0 would be my x, which is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 270 is 0. Cosine of 360 back here at 1. So again, one whole period ends up being 2 pi. On my x, I have 0. Then I have 4 markings from there. I have pi over 2, pi, 3 pi over 2, 2 pi. My y's, again, vary from negative 1 to 1. So I have all my axes labeled. Now I'm going to go ahead and plot these points. 0, 1. Pi over 2, 0. Pi, negative 1. 3 pi over 2, 0. 2 pi, 1. And then I'm going to sketch through those points. And again, I come out beyond those points in the cyclical manner that it would continue to the left and to the right. So if we look at our domain, all of these x values are used because this keeps on going left and right. So again, x is all reals. My range, again, from negative 1 to 1 are all my y values. So what was the amplitude for this function? What was your a here? It is a 1. And what is the period? What did one cycle take us from? 0 to 2 pi, which gives me 2 pi units. Okay, so let's go ahead and try some graphs. This time, y equals half cosine x. The amplitude is your a, which is 1/2. My period for cosine is 2 pi. That's how I got one full cycle. So I'm going to label my x-axis 0, 1, 2, 3, 4, pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi. Since my amplitude is a half, if this is 1, I'm going to mark this as a half. So this would be negative 1/2, and this would be negative 1. So now I'm going to plot my cosine function. Cosine started at 0, 1. But ours is not going to be 0, 1. Instead, we're going to have 0, 1/2. Because our amplitude, our stretch, is only 1/2 of that. Then we go down to the 0, down to the negative 1/2, back to the 0, back to the 1/2, and sketch through. So as you can see, your domain is X is all reals because this is going to continue on the left and the right in the same pattern. And my range, this time my highest is 1/2 and my lowest is -1/2. So I go from -1/2 to 1/2. I'm going to take a moment and just go back here again. Let's go back to sine. We see, where does sine begin? It begins at 0, 0 for one cycle. So when we have sine, you begin at 0, 0 and you end at 2 pi 0. When it comes to cosine, it began at 0, 1 for our period. And notice since we're starting at 0, 1, that is called up. We always come back to the midline 0, down, back, up. The same happened with sine. But sine began at 0, 0. So then we went up, back to 0, down, back to 0. So let's check this one out again. Cosine. Cosine begins at 0, 1, but since we have a vertical stretch of 1/2, it's 0, 1/2. So we start up, back to 0, down, back to 0, up. Now our next one is sine. So what is the amplitude of sine on this one? Well, my A is 3, so my amplitude is 3. My period for sine is 2 pi. So again, I'm going to put these values on my x-axis. This is 0, pi over 2, pi, 3 pi over 2, 2 pi. This time, instead of running from 1 to -1, since my amplitude is 3, it will go from 3 to -3. So now let's begin our points. Sine begins at 0, 0. So then we go up, back to 0, down, back to 0. And let's sketch through those points. Remember, we're going beyond because it continues to the left and to the right. So my domain is x is all reals because it's cyclical. My range went from -3 to 3. All right, I just want to show you something here. Mathematically, we are going to factor this to see what happens. So if I factor this, I get 2 times x minus 4. So it says, notice the size of the values in the parentheses compared to the original function before it was factored. So how does x minus 4 compare to 2x minus 8? X minus 4 is half as big. So when I factored out a 2, what remained was half as big. Let's try the same thing down here. If I factor out the 1/3, I get x plus 6 divided by 1/3 is 6 times 3 is 18. Again, how does x plus 18 compare to 1/3 x plus 6? It is 3 times as big. Well, notice my factor was 1/3. So how did I get these factors? I took the 2x and divided by 2, and I took the 8 and divided by 2. Here I took the 1/3 x and divided by 1/3, and the 6 and divided by 1/3. We're going to do the same with our trig functions when we graph them to find our periods. So let's take a look here. We have y equals cosine of 4x. My amplitude is still a 1. Notice this time I have 4 times as much in the B position. So normally my period for cosine x was 2 pi. Well, just like back here, I factored out the 2 to see what one cycle would take. I am going to also factor out this 4 to see what one cycle will take. I know that cosine's period is 2 pi, but if I'm going to factor out a 4, that means I'm going to divide out a 4. So 2 pi divided by 4 actually gives me a period of pi over 2. So I have my 0. Now, I'm going to show this to you because pi over 2 was my first tick. Well, what I need to do is this should be, by dividing by a 4, it should be a 1/4 as big. So this is as far as my whole sign should stretch. So B will be a horizontal stretch. So I'm going to divide that into fourths. So every tick mark is divided your period into fourths. So my period is pi over 2, and I'm going to divide that into fourths. That gives me every tick mark is worth pi over 8. So this first one is pi over 8. Then I have 2 pi over 8. 2 pi over 8 is pi over 4. 3 pi over 8. 4 pi over 8. 4 pi over 8 is pi over 2. And it does work out. It still reaches a height of 1. So I have 1 and -1. It was the cosine function. So cosine starts at 0, 1. Then I come to the 0, down, back to the 0, up. And I'm going to curve through those. Do you see that I was only a 1/4 as wide on this one compared to this one? Your domain is still x is all reals. Your range is from -1 to 1. So let's try sine of 1/2 x. My amplitude is still 1. My period for sine is 2 pi, but I need to divide out a 1/2. So 2 pi divided by a 1/2 is the same as 2 pi times the reciprocal of a half, which is 2, which gives me 4 pi. So my period is 4 pi. So I have 0. Then I should have 1 pi, 2 pi, 3 pi, 4 pi. So I should be 4 times larger, or excuse me, twice as large. Notice a normal cycle of sine happened between 0 and 2 pi. We are stretching that twice as far. And our amplitude from 1 and -1. And I'm going to plot my points for sine. Sine starts at 0, 0. Then I go up, back to 0, down, back to 0. Do you see how this stretched horizontally further rather than vertically? My domain, still x is all reals because my cyclical function takes place all the way through the x-axis. My range went from -1 to 1. Let's try 3 cosine 2x. My amplitude, my A, is 3. My period for cosine is 2 pi, but I have to divide out the 2. So that gives me a period of pi. So here's 0. Here was pi, so I have to divide that into fourths. So every tick mark will happen. Pi divided into fourths is a pi over 4. 1 pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4, 4 pi over 4, which reduces to pi. Amplitude was 3. 1, 2, 3 up, 1, 2, 3 down. Notice every marking on my x-axis and my y-axis is labeled. Now I'm going to plot cosine. Cosine started at 0, 1, but with an amplitude of 3, it'll be 0, 3. So I start up, back to 0, down, back to 0, up. And now I'm going to sketch through those and keep curving around. Domain, x is all reals because it is cyclical on the x-axis. Range went from -3 to 3. Let's try another one. Y equals 4 sine of pi over 4x. Amplitude A is 4. Period for sine is 2 pi. I must divide my B, pi over 4, out of there. So that becomes 2 pi times the reciprocal 4 over pi. Pi's reduce, and I get a period of 8. So this was my 0. Let's see, 2 pi is 6.28, so we'll just say 8 was here. And I need to divide that into fours. 1, 2, 3, 4. So every tick mark, my period is at 8. I need to divide it into fourths, is 2 away. So this is 2, 4, 6, 8. My amplitude was 4. 1, 2, 3, 4. And 1, 2, 3, 4. Down. Ready to plot my points. Sine started at 0, 0. Then we go up, back to 0, down, back to 0. My domain, x is all reals because it is cyclical on the x-axis. My range went from -4 to 4.